Hello everyone, in this video I will present you how I built this robot arm under $100 and how it works. In the first part of the video I will present how the arm works, and in the second part how I made the entire project. As a demonstration, we need an Arduino Uno, some wires and a servo motor. We connect 3 wires to the servo, 1 to 5 volts output, 1 to ground and 1 to the third pin on the board. After this, the connection should look like this. Now we are making the code. This code is only made for one servo motor, but it can be made for more motors in the same way as is made for only one. With this code, we can turn the motor in which direction we want. For example, we put the motor to rotate at 90 degrees and after 2 seconds to 180 degrees. The motor will do exactly what we wrote as long as it is connected. We can use this setup only if we want the arm to make specific movements, like taking things from a place and put them in another place. If we want to control the arm in real time, we can add to the configuration a potentiometer. We read the voltage that comes out of the potentiometer, and so we can position a servo motor exactly at the angle we want. We connect the potentiometer to pin A1 at 5 volts output and to the ground. The code is not much different, we just have to read the data from the potentiometer. The values we achieve, which are between 0 and 1023, we transform between 0 and 180 degrees, and then we send them to the motor. So now, when we rotate the potentiometer, the motor is rotating in exact same position. If you want to make the arm that you can control using potentiometers, then you can also make the one with certain moves. All you have to do is enter the specific code. This is the base code and how every motor from the arm is controlled. Next, we will move on the composition of the arm that is controlled by potentiometers, because it is much more complex than the one that only makes certain moves. This is how looks the entire project. The main part is the arm. The arm is full 3D printed on my Ender 3, which is a very cheap and very good printer if you know how to make the settings. The models for the arm are made by Mechatronics, so big thanks to them. The arm has 6 axes. The first 3 axes have an MG995 servo motor. These motors can move things up to 10 kilos. The gripper has 3 motors MG90S. The motors from the gripper are pretty weak. They can only move things up to 2 kilos. So the arm cannot lift heavy weights, like a bottle of water. With the gripper, I had some problems because there was too much friction and the motor was heating up, so I suggest you to buy the gripper. The second part of this project is the control system for the arm. The control system is made up of 2 parts. The first part is the part that controls the first 3 axes, which are composed of the big motors and is like a mini version of the big arm, because in which position is the little one, in the same position is the big one. In this way, we have a much more precise and easy control over the arm. The second part is a breadboard, where are another 3 potentiometers that controls the gripper. All the potentiometers are connected to the analog pins of the Arduino, and they also have power from the Arduino, even if the potentiometers from the mini arm are connected to the PCB. The connections are made in the same way as I presented you at the start of the video. You just need to add in your code every potentiometer. The big motors of the arm are connected to the big battery. The battery has an output of 11 volts, so I used a voltage regulator to decrease the voltage to 6 volts. The motors from the gripper are connected to the 4AA battery, so they have 6 volts. All the connections with the batteries are made on the mini blue breadboard. To connect an external battery to the servo, all we have to do is connect the ground of the battery to the ground of the Arduino, and after all the motors to the battery. The entire project cost around $100, which is extremely cheap compared to the arms on the internet. The most expensive thing was the large battery, but can also be replaced with a smaller one. As I mentioned, the arm is not strong, but is very easy to build and cheap. The project is done and I hope you like this video. The code for the arm and the links to the most of the components used in this project are in description. Leave a like, subscribe, and I want to thank you for watching.